In this video, we will see how the visual analysis of regional anomalies in the myocardial motion is performed. Let's take an example of a healthy dataset. The user would first of all like to get an overview, that is, user would like to see the information about all time steps in all segments of all three slices and all three velocity directions. Hence, the user would start with a 3 by 3 radial functional box plot view. Since analyzing these data is rather complex and visual complexity may be overwhelming, the user needs guidance, which we provide by starting with difference plots. How we proceed from here depends on the individual case. For example, if we are interested in analyzing a single segment, we can simply click on it and it will open the functional box plot of that segment. We can also switch the view to regular functional box plots that show healthy regions at any time during the analysis. The selected dataset is overlaid on the healthy regions. The user can click on any segment to further investigate that region. The view can be switched from difference encoding to non-difference encoding to see the actual time series and the healthy regions. If the user clicks on a segment while holding the Shift key, it will open a 3 by 3 view of functional box plots for all slices and velocity directions of that selected segment only. Now, let's take an example of a patient dataset. This dataset belongs to a 50 years old male patient who is diagnosed with dilated cardiomyopathy and has 40% ejection fraction. We can see there are strong differences in several plots. For instance, in the middle slice, the circumferential velocities in the systole appears abnormal, especially segment 7 that has been marked as a statistical outlier. If we see the non-reference encoded regular view, we can observe that the patient timeline in the systole has different pattern than all other healthy data sets. And also there are several segments marked as abnormal in the apical slice for the circumferential motion. And now if we see the longitudinal motion in the base slice, we see that the right side of the heart in the systole shows stronger deviations than the left side. Let's examine one of the segments on the right side of the heart. In the regular non-difference encoding, we see that in systole, not only this segment reaches its peak later than the healthy datasets, but also its amplitude is very low, which indicates the low ejection fraction. On the other hand, the segments on the left side of the heart appears to have normal pattern.